So, hello, everybody. I am Adriana Cabrera. I am scientific assistant in Hochschule Rheinball. And we are working in an amazing project, 3D Competence Centrum, in which we are contributing and promoting the knowledge about digital manufacturing in the region of Niederrhein. So I am Colombian. I am coming from Colombia. Long travel until coming to Germany, but maybe I know that here there are a lot of students that has an idea. Maybe you want to go in another country and find a nice destiny. And I was hearing about Germany as a country of opportunities. But yeah, I think that it was a right decision because actually I found these opportunities in this place. And one of my most important things about designing was try to combine all of these traditional techniques that we have in Colombia, but not only in Colombia, but also how we can contribute with this digital technologies with traditional techniques. And therefore, I developed this project about mediated surface under coding, in which I took a technology about QR codes and challenging myself also trying to combine the accuracy of these QR codes in textiles and how I could combine the haptic part of textiles in between digitalization and tangibility. So I have like a magic world, as we are always having in Colombia, but also at the same time how I can combine this technology. So when I came to KAMP-LINTFORT, was an amazing place. It looks like this, actually. It was a new challenge, a big challenge, creating the biggest fab lab in the world. So imagine that it sounds like crazy, but actually in that time it was the biggest place in which we could create a fab lab. And when I was applying through Arbeitsagentur, I like, yeah, it's true. So I was very excited about the idea, and I have several opportunities to do things, working on the evening, and I was doing, my first task was working with building 3D printers. But especially this model of 3D printer is a RepRap, that is a self-assembly 3D printer in which it can reproduce themselves. It means that I can print the parts, buy the orders in OBI and in electronic shops, and I can produce this print. And imagine that it was very nice, but at the same time, a lot of nice frustration around it is not working, but at the end, when you see that it's like a nozzle and a piece of filament coming out, it's like, yeah, you got it. Well, but at the same time, we were in a university about communication and environment. And for us, or for my colleagues, FabLab was an opportunity to combine all these technologies and combine tangible interaction with something interactive. So we developed this project that is Passion Play with my colleagues that is here, Jana Lina Berkenbusch and Thomas Laubach, developing these nice posters. I think that we are missing the sound. Yeah. Yeah, imagine that around this smartness that we wanted to produce and how we can look new ways of communication through posters. And it was a very nice idea combining screen printing and electronics and phones. Yeah, this is a lab of invention. So we were working in diverse disciplines. As you see, I was the first scientific assistant in the Fab Lab, working with a really big guys, and I was the smaller one, always in all the events. I am here. So, and also working with big machines, but also with a lot of engineers. And through all of this interest, imagine that I am a designer that I want to work with, industrial designer, media, communication, textile material, interaction, sustainability, and human being. But this approach as a designer, and also looking the approach of my colleagues, I had to deal with these desires that all of us wanted. So we see that we have this process that is very linear, but for me it looks more like practice and theory had a very huge gap. So when I wanted to do something in the process that I am I wanted to think about another things, materials and 3D printing, and it was like, what are you thinking? Because we are dealing with chaos. So what about this chaos? I discovered, and it was like the very nice part about BIONIC, that they propose this combination about biology and technology, and how I can solve problems. And this is nice. Professor McGill showed me a paper about it, about Julian Vincent combined how we can deal with the combination in between problems solved by nature and problems solved by engineer, that it's very different. But at the same time, we see here that, for example, with this piece of bamboo, that we have a really light structure with a really nice combination of pipes. And this is today what we are doing exactly with 3D printing, giving this git or structure. But at least it looks not so beautiful as this piece of bamboo. So now I need my colleague Daniel Ingracia reading this sentence. What I found in Italy, and I love this sentence, the most extraordinary thing that a machine can do is be human. It's because we are trying always to simulate this smartness of body. Imagine that we are eating a piece of potato each day, and this is the enough energy for the whole day. And what we are doing big fabric companies with a lot of materials, with a lot of energy, smart cars, smart phones, smart factories, but we are not taking care about what we can affect also because the resources are limited. But at the same time, digital fabrication can deal with this complexity, because when we are talking about smart things, smart objects, we are dealing with this complexity, and this is that we have to try to understand how we can minimalize material, how we can minimalize the use of energy, and how we can do also, for example, things that before was hard, and now I can do this flexible. But before talking about digital fabrication, digital manufacturing, we had to understand the matter of fabrication. And this is something that I began to explore, because dealing with this whole chaos, my first thing that I thought is that I have to understand things, understand how, which materials we have, which techniques we can use. And for example, here we have the sewing machine that is one of the first machines before the computer that you could use at home. And you can use for making prototypes that at the end you can use. And it was very precise. And yeah, today we are standardizing a lot of things, but if you see this, the first picture about a 3D scanner, this is my body. And yeah, it looks like, maybe I don't look it. No, it's different, but yeah, it is my body. And what had this body in comparison to your body? Nothing. Nothing, because we are persons, we are individuals, and we can also address this kind of production, or not production, but individualization in the FabLab. And with this 3D scanning, we have also the possibility to get different kind of results through the techniques that we have here. For example, this is my face in wood, but also a piece of thermoform material. But at the same time, we have a nice possibility in the university, and also because we are working with environment and how we can do also an impact, we have to understand also the past, and sounds a little bit that we are in the trend. That we have all techniques that we can also combine today and analyze our present in order to understand it and see the future. And this is a piece of experiment with dying with bacteria that we did in the BioLabs, the Hochschule Rheinbad. And what is interesting for it is that it's one of the most sustainable techniques for dyeing textiles. And don't worry, you can wear it. It is not bacteria around it. But maybe I am not a biologist, but I think that this can contribute for my creative process in the future. We have also digital materials. And what about this is because imagine that I can do a model that I drew today, but I can also use these models in other part of the country, in other part of the world, and it will look totally different because we can do things open source. We can also reuse materials, doing, for example, modular constructions. And at the same time, this digitalization enables to do different properties that maybe we don't find in materials in nature. And this is, for example, a digital model that we did and printed with different materials. And in the first one, we see that it's a flexible material, but actually it's very stiff. And you can create also a material that it's lightweight, but at the same time that resists the impact. And the other one, it is a rigid construction, but at the same time you can actuate for the squares. And maybe it's not like something that we will do in future. We will do a final product, but it's something that we can use for understanding the nature and apply for other processes. This is something that we are developing in the last time that has solved robotics. It means that we are working with simulating living organisms and simulating it in the way that we can create very soft movements through pneumatic. But what happened with this all understanding? So that we can also adapt our technologies and think about 3D printing. We have it's a technology that has also my age, sorry. And we have to understand it, but also we can hack it, we can make it different, we can do our own system, for example, printing on textiles or making different shapes, because this is the challenge for us, that we are in this development of the technology. Or if you want, you can do your own machine. So this is a nice project that we developed during the program that we offer in the FabLab KAMP-LINTFORT, the FABRICADEMY. And we did this small machine about planting seeds on our parks. And imagine that we did this in a week. And for the other side, we have a machine that is developed my colleague Daniel Ingracia, who needs a machine that works differently. And if you see in the picture behind the machine, we have the original one that it's very small. Because I was telling Daniele, but why if I can cut a piece of textile, this machine is too small. Please make one bigger. So and now he's cutting this, having other features that we can use for example, cutting metal. And this is very nice, that we are capable to do our own tools and, to change the story of machines. For other sides, we have the possibility in the Fab Lab to work for specific needs. And returning for the human being, we can just offer solutions that the system cannot offer. And this is a project that I developed during the Fabricademy. There is an orthesis for a patient who had a paralysis in his left arm. And it was a very nice project because I didn't have to look for a patient in Colombia. I found the patient in Nottingham Flu, and he was very excited for having the possibility to move again the hand, and because he couldn't do rehabilitation or recover the movement. And this project inspired also other projects that I developed this, and after I developed a second version that could be used also for cases for first need, and also in humanitarian field, in the global humanitarian lab, that it's a picture from David Oud. He addressed this develop of the orthosis for how makers can do impact. But one other point that it's very, very important is that in the Fab Lab, we have to have this knowledge that it's permanent, that we can keep this knowledge, but at the same time share it. And therefore, documenting is a very important step that we have to do. And therefore, we did this Fab materials. There is an archive of materials that we develop in all this process, and said that we are not working only with wood or with plexiglass or with normal forms. We have a very nice area in which we can experiment. So we are sharing also knowledge. And what I thought about that it is very nice to have in a region activities as Make a Day in Duisburg, in which we are trying to explain also people how you can, for example, do these materials and use digital fabrication. And one of our main goals is that this transfer knowledge and bring all of this experience that we are doing and understand that making by doing bring a very nice outcome for not only for the students, but also for us, being also open source and documented and be very creative. And this is an academy that we did in the last, this year, at the beginning, let's year. The name is Fabricademy. We did this academy with 15 countries around Barcelona, Amsterdam, Peru, and we did a first country here in Germany, first city in KAMP-LINTFORT, with the topic personal fabrication for care, in which we have the students learn about different assignments and different techniques in order to work with soft materials or smart materials and digital fabrication. This is a project of the student that she developed an app for people who has disabilities, for example, for the feet, and they cannot really measure the weight. And always that you have this therapy, you have to go to the doctor, and he said, like, yeah, maybe a little bit more, a little bit less, but never you understand how the role, for example, because you are not therapist, then how you can understand it better. Then we can develop also technologies in order to understand this better. But we don't have only disabilities that are physical. And this is a very nice project about an inflatable chest belt that supports the people who has anxiety, as me, here talking with you, and that help you to calm down and to have a better breathing. And if we see here, this huge complexity of about, maybe it's only a chest belt, but it's not. Because you have a system that has an inflatable, you have a sensor that was built by the cells in number 1, You see that she experimented a lot. She built their own electronics in order to have a system in one. And this is the last project that I will introduce to you today. It's emotional, that reacts for emotional changes. This is Under My Skin from Esin Dumas. She developed also this nice garment that reacts or simulates the behavior of animals, and how, for example, we as people, as human beings, we can react in the same way, reading our signals of emotions when you are excited, and how you can create it and express ourselves, because this is also communication. Well, at the end, we are building a community, a very nice community in which we are developing several activities in which we are students are developing, for example, hackathons, but for people with disabilities, that is the Accessathon. We are developing programs for teachers, but also for schools, promoting the idea of digital fabrication, and we are promoting programs for students in order to extend this community. And we are working together with different FabLabs. At FabLab Boldrop, we are working with FabLab Aachen, but at the same time, we are working with a very good community that is the Fab Foundation. And yesterday we were talking about KAMP-LINTFORT is smaller, but actually it's a very good place in which we are big digitally. And now I will show you some activities that we are doing in the Fab Lab. Thank you so much for your attention.